Good day to you. This is teacher Leland, Alejandro, and we're going to discuss today the change of base formula in evaluating logarithmic expressions. So, change of base formula in evaluating logarithmic expressions. So, we're going to see the examples in the problem set. Let us see the problem set in the other screen. Okay. Here's the problem set, evaluating logarithms by change of base formula. So the instruction is use the change of base formula and a calculator to evaluate the following logarithmic expressions, then round your answers to the nearest thousandth. So we have about 8 questions. Okay, so let us see in the presentation view. Here's the first number. So we have logarithm of 32 base 5. Now we shall have the change of base formula first. So this is the way to do the change of base formula. So the change of base formula is something like this. It has the format log A to the base B. Then you can use another base, say base 10, okay? Base 10, you don't need to show the base, okay? But in reality, it's supposed to be like that, okay? And then you can put the expression A here and a base number in a separate logarithm, like this. Of course, you will have to use the same base. So in other format, then you can express your formula like this. Say log A to the base B, and then a ratio of 2 logarithms, and you can take on any base, okay? Any base, say base X, and then using the same expression A there, and you have to use the same logarithm in the base X, and the base here becomes the argument in the second logarithm at the denominator, okay? And so this is how you make use of the change of base formula. You can make use of any base. So this log A base X divided by log B base X, this A is this number, and this B is this number. That's how to make use of the change of base formula. Okay, and so we're going to apply this in the first number. Let me remove the formula. Let me clear the screen. So we shall start with the given. So we have here logarithm of 32 base 5. So we can make use of base 10. So this is simply logarithm of 32 divided by logarithm of 5. There. And so you can use your calculator values here, and we shall compute logarithm of 32, and that's equivalent to 1.505 together with 14997. Let's write all the digits, and then this will be divided by logarithm of 5. And so this is 0.6989700043. And then you will simply divide, okay? All right, so we'll just divide this. And this will be like 2.1533827.9. So the answer is 2.1533827.9. Okay, the complete approximate value of logarithm of 32 base 5. There. So this is our answer. Okay, it says here, round your answers to the nearest thousand. So it will be 3 numbers to the right of the decimal point. So this will be 2.153. And so we can verify the answer from our database there. Okay, over here, below the given, you can see the computer's answer at 2.153. This must be the right answer. Let's proceed to the second number. Okay, here's the second. Use the change of base formula and the calculator. So the given is logarithm 65 base 4. And you can make use of logarithm of 65, a logarithm of 4. Okay? And so we get these values from our calculator. Logarithm of 65, this will be 1.8129133357. And then we take on the logarithm of 4. This will be 0.6020599913. This is 9. All right. So we'll just divide this, and we shall get the answer. And this is equivalent to 3.01183907. Rounded to the nearest thousand, this will be 3.011. Check and verify from the computer. We had 3.011 over here, there. So this must be the right answer. All right, let's continue with the third. We only have 8 examples of the change of base formula. We're doing the third now. Here's the third. Okay, very simple. Logarithm of 4.1 base 3 is logarithm of 4.1 divided by logarithm of 3. And we can take on the values from our calculator. Logarithm 4.1, this is 0.6127838567. And then logarithm of 3, we have something like 0.477, decimal point is there, 1212547. So we will just divide this. This will be logarithm divided by, and you have something like 1.284335692. And then rounded to the nearest thousand, this will be 1.284. There. And we can check and verify. 1.284 is the answer over here. Number 4 now. Let's continue with number 4. Here is the fourth number. Use the change of base formula in your calculator. Find logarithm of 45 base 7. Logarithm of 45 base 7. So this is just logarithm of 45 divided by logarithm of 7. So we will write everything in detail. This will be logarithm of 45, and this is 1.653212514. And then we have logarithm of 7. This is 0.84509804. 9804. There. And so we will be dividing this. We have something like 1.95. 6237543. And rounded to the nearest thousand, this will be 1.956. Okay, and we have the logarithm of 45 base 7. Okay, check and verify. There, 1.956 over here. Yeah. Number 5 now. Let me clear the screen. Let's continue with number 5. Here's number 5. The logarithm of 6.75 to the base 2 is equal to, let's use natural logarithm. Natural logarithm, say ln 6.75 divided by ln of 2. That means our base is the base e. Okay, the base e. The base e is 2.7182818828. There, that's base e. Okay, that's the decimal point. All right, so we will take on natural logarithm 6.75. This is 1.909542505. Then we have ln2. This is 0.693147931471806. So all we need to do is divide, okay, and we will have the answer, okay? So we will just divide here, okay? So we have the answer 2.75. This is 2.75 4887502. Rounded to the nearest thousand, this will be 2.755. 2.755 rounded to the nearest thousand. Okay, so you can use any base. Okay, this time we use the natural logarithm. Here's the answer. There. Okay, that's 2.755. All right, and so we'll continue with number 6. Let me clear the screen. Here's number 6. All right, logarithm of 5 base 4. Logarithm of 5 base 4. Okay, so we'll use logarithm of 5 divided by logarithm of 4. Let's take the value of logarithm 5. Okay, this is 0.6989700043. This is to be divided by logarithm of 4. Logarithm of 4 is 0.602059913. And so we will divide it. We have the quotient is the answer 1.160964047. Rounded to the nearest thousand, this will be 1.161. There. And so we will check and verify the answer. Is it 1.161? Yes, it's 1.161. There. Number 7. Let's proceed to number 7. Here's number 7. Logarithm of 3.2 base 3. Logarithm of 3.2 base 3. We shall try doing using the natural logarithm 3.2 and ln3. This must be ln3. So we'll use natural logarithm. Okay, ln 3.2, ln 3.2 is equivalent to 1.16315,081. And then ln 3, we have 1.098612289. So we will just divide this, and we have something like 1.0587, 1.0587, 45494, 45494. Rounded to the nearest thousand, this will be 1.059. There. Okay, check and verify. 1.059. There. Okay, so that's 1.059. Well, I can show you the other way of doing it. Okay, we can do it by the logarithm base 10. Okay, all right, let's do it that way. So let's move the numbers here. All right, we shall continue by the base 10. This will simply be log 3.2. This is log 3. There. And so by using logarithm 3.2, this will be 0.5, 0.51499783. This is to be divided by logarithm of 3. This is log 3. This is 0.4771212547. There. And so we will just divide this. Divide it by, you have 1.0, yes, 1.058745494. Okay, rounded to the nearest thousand, this is the same 1.059 there. So it won't matter whether you use base 10 or natural logarithm base or any other base, it gives you the same answer, okay? There. So let's proceed to number 8. Let's do number 8, the last number. All right, here's the last number. Logarithm of 40 base 2. This is logarithm of 40 base 2, okay? This is 40. And this is equivalent to logarithm of 40 divided by logarithm of 2. So we have logarithm of 40, that should be 1.602059991. And then we have logarithm of 2. This is 0.301029997. And so we'll just divide this. Okay, so this will now be equivalent to 5.3219 28095 28095. Rounded to the nearest thousand, this is 5.322. And that's it. Let's check. There is the answer over here. Okay, so this is the answer, and we're done with all the 8 examples. I hope you were able to learn how to use the change of base formula, and this will be in evaluating logarithmic expressions of which you cannot relate the argument with the base. Okay, that means you cannot relate the 40 and the 2 using the powers of 2, and you can only resort of using calculator and the change of base formula. So I hope you were able to learn how to use the change of base formula in your scientific calculator. We'll see each other again for other topics in math. So this will be all for now. See you later. God bless.